Now, without further ado, it is my pleasure to introduce to you Mr. Mike Lehan. Um, Mike has been working in web application development using PHP for 12 years. 12 years. You kids amuse me. I got socks older than that. No, Mike has been working using PHP for 12 years, including time as a CTO and startup founder. Through working on business critical systems with real-time elements, Mike has learned the value of comprehensive logging, monitoring, redundant checks on applications and infrastructure, and of course, well-written, testable code. And I love this. He has a strong desire to train and mentor the next generation of web engineers. So without further ado, I'm going to toss it over to you, Mike. Take it away.
Thank you very much, Cal. Hopefully people can see and hear me, and I'm sure that someone will buzz me if they can't. As Cal mentioned, my name is Mike. I'm a software engineer based in the UK. I'm CTO at a prop tech company called StuRents. I'm a skydiver. Feel free to talk to me about that. And you can follow me on Twitter at M1KE. As Cal said, please do consider giving feedback after this talk on Joined In. Myself and all the other speakers love to receive it. And I just want to say thank you to DPC for having me again to speak this year. It is a shame that we can't all be gathered together in Amsterdam, but I look forward to seeing all of you there, hopefully next year. Let's make that happen. Let's make a big party happen. Today, I'm going to be talking on a subject which is love your monolith. And this is a bit of an opinionated talk. And I want to start by clarifying that. What I'm not giving here is a set of academic technical arguments. I'm giving an opinion, and the opinion's from my years of experience in software engineering. And it's an opinion that I think can help people who might go to conferences, might go to talks like this, might read blogs or watch people streaming on Twitch or other things online that they consume and consume other people's opinions themselves. And when they do so, they might get an idea that the way they're doing things is just wrong. And they might feel that the way they're doing things is bad, that they are not as good as a result. And I want to offer a slightly different perspective today. I want to talk about monoliths and microservices, two quite common topics for talks, two quite common architectural patterns, and get into the details of why they are different and what the underlying reasons are why we might pursue one or the other. I want to give us an idea about some better principles we can follow. During the talk, we're going to learn about how monoliths are perceived, especially in comparison to microservices. We're going to learn about principles that guide our architectural decisions and which microservice practices can hint at better principles. Finally, we're going to talk about the practical side of things, how to get microservice advantages in your monolith. And the reason I'm particularly keen on this is because when we build systems, and especially when we hear about the latest cool thing, it's always tempting to tear them down. And as someone who's not just an engineer, but a CTO on the business side of things, I'm aware that there is definite business value in what you already have versus throwing things away and starting new. And I want us to start considering that as developers in the field to see not just what we're building, but why we're building it, how we're building it, and what implications our decisions have on the business and, in fact, the world around us. So to start with, the monolith. Monolith is a term that has a variety of meanings. Many of you will have heard of the term monolith, but I'm not going to assume everyone has. Some of you might have been building monoliths and you don't know it. It implies a large or singular code base for an application. Many off-the-shelf applications, such as Drupal, Magento, WordPress, are monolith in structure. And that's why actually this talk's quite relevant to the PHP world in general. And there are arguments as to how modular a system can be. So is using plugins in WordPress or composer packages, changing your system to be more modular, is that making it not a monolith anymore? I would generally say that it's probably still a monolith. Microservices is quite distinct, but there is a gray area between those things. And a monolith is often considered a traditional form of architecture. And traditional is a loaded word. Traditional to some people can mean outdated, past it. We need to be progressive and move on. Traditional to other people can mean established, proven, something we enjoy and we like. And so it's important to consider why all these opinions exist. And I want to start with why. Why are we building monoliths in the first place? Because I'm going to hesitate to say most of you here will have built a monolith. I don't know whether you set out to build a monolith, but I think you've probably mostly built one, or at least worked on one. Why are we building monoliths? It's because software evolution is messy. It is rare to start a project with a concrete plan of what we're doing and where we're going. It's rare to have a full idea of the path ahead of us. We might be prototyping an application. We might be experimenting. We might be starting a little open source library and wondering whether anyone will ever use it. But we often don't know where we're going when we start. And we have a few mechanisms in the software world, and these kind of extend outside technicalities and into sort of business management as well, to plan our software. One of these is the waterfall process. So in waterfall, it's called waterfall because we write a series of steps and we put downward lines in between them. We have a set of processes that you follow one at a time until you get to the end. So you start at the top and you go to the bottom. With waterfall, water does not flow back up a waterfall. And this process was taught, I was taught this when I studied computer science. Waterfall was the how you build software process. And obviously in the last decade or so, you will probably be aware that waterfall is not the be-all and end-all of software methodologies anymore. We use agile processes. Now, agile itself isn't a process. Agile is a mindset, a methodology, but often it's conflated with a process. And one of those processes is sprints. And we say everything goes round in a circle. It's iterative. We do it once, and we do it again, and we do it again, and we do it again until we reach the finished result. And what you'll notice when you look at this sprint diagram, and this specific one at least, is that sprints is just taking the waterfall and attaching the end to the start. It doesn't do anything massively beyond that. And in reality, our software processes don't look like this or this. Our software development process tends to look like this. This is not a diagram of a software development process. It's a diagram I got from going onto Google and typing messy flowchart. It looks like some sort of accounting system. Maybe some of you can read it. That's not the point. The point is that this is what most software development looks like. It's messy. It is full of unexpected turns, unexpected changes, unexpected pivots, full of problems we have to fix, full of delays, full of team members getting ill or going on holiday. This is how we tend to develop software. And the result of developing software like this is the monolith. And this diagram is from XKCD. The diagram is actually not intended to illustrate monoliths. It's intended to illustrate the problems of relying on specific open source packages. But this is what a monolith looks like. It's not a large carved lump of granite. It's not a sculpture, a single piece, but it is a large construction where the things at the bottom are generally stabilizing and providing a base for the things on the top. If we remove any of the things from the bottom, not just that little one that's got an arrow to it, but any of those items at the bottom, everything above will come crashing down. And in fact, if we move things at the top, the ripple effect can still spread through the whole structure and bring it down as well. This is what a monolith tends to look like, a large structure, but still comprised of individual parts. So microservices. The Wikipedia page for microservices says they are a form of service-oriented architecture. And after I've said that, you're none the wiser as to what they are. But they are taking your systems and decoupling them, splitting apart different domains in your system into separate services. And generally, the services have a protocol, a commonly established protocol handling communication. HTTP is one such protocol. gRPC is a slightly newer protocol that some people have started using in microservices as well. And the goal of microservices is generally to split systems by business domain. So taking the parts of your business and mapping them to individual services which have interactions. The microservice term evolved around the mid-2000s. There's no canonical meaning. Looking at literature, it popped up in a few different spots of literature at the same time. Some people may disagree with me on that, but that's what I could find from doing some research. And so we have the comparison between these two forms of building software. And these comparisons are maybe slightly subjective. We'll see that in a moment. Monoliths are associated with heavy coupling, systems being very heavily linked and intertwined. Microservices promote decoupled systems. Monoliths, by their very nature, are decentralized, and microservices, again, by nature monoliths are centralized. Microservices, by nature, are decentralized. Traditionally, a monolith might be hosted on a single server. Microservices generally will be in a networked system of servers or on containers. And this is where it starts to get more subjective. Monoliths are perceived as having a single point of failure, whereas microservices can be more resistant to failures. A monolith will almost always be programmed in a single programming language, whereas the microservice gives you an option to use multiple programming languages. I don't know how often people take that option up. And finally, the most objective statement: monoliths are hard to maintain, microservices are easier to maintain. But as I say, that's just like your opinion, man. There is a lot of opinion, there's a lot of subjective nature going on around this. And there's a lot of going to talks or reading blogs about some way some other company's doing it and thinking, oh, that's just so much better than the way I'm doing it. And it means that I think a lot of our decisions about moving architecture types or what architecture type to use are driven by FUD, fear, uncertainty, and doubt. We're not picking these systems because they are the best for us. We're picking these systems because we're afraid of what goes wrong if we don't. And that can go both ways. But I think when we're having one system promoted to us quite regularly, we can assume that we are somehow lesser if we don't go with that system. Myself, in interviews, when I'm interviewing candidates, I've occasionally been asked what our architecture type is. And I sort of say monolith as if I'm a little bit ashamed of it, which is crazy given I'm doing a talk for you about loving your monolith. But I think that's why we need to think about loving our monolith, because maybe we feel a sense of shame that we have built one and that's not what we should have been doing. And underneath all of this is a question. It's not about the architecture type. What do we really want? I'm sort of going to clarify a few ideas of systems that we can get from a comparison like this. We want to build systems that are logical, that are stable, and that are flexible. Now, what do I mean by those? Logical systems, systems that are easy to reason about. Given certain inputs, what are the outputs? And given the knowledge of my business, my structure of my company, does my system match that? Stable systems, we want options of where we host, which platform we use, how we provision and test our services. We want resilience to failures at levels we can't control. We control our code. We don't generally control the CPUs of the machines that our code runs on. We don't control the status of the operating system often. We definitely don't control the capability of the network, if anyone's been following the Cloudflare outage this week. And flexible, we want to build systems that can evolve. As I mentioned at the start, we often don't know where we're going when we start. So we need systems that can grow in a sort of organic way, grow with the teams, grow with the knowledge that the developers are acquiring about the business case. We also care about innovation. We see new tools be released. We see new frameworks come out. We want to experiment with them. Are they good for us? Will they help us? And these are the core principles we're going to look at. Before we do, I'm going to specify, I guess, an axiom. I don't think anyone's ever named anything after me, and I don't expect anyone to, but here's my go at writing something that's vaguely quotable, and feel free to take it on or completely disregard it. But I think that your choice of architecture has less impact on the operation of a system than the principles you follow because of that choice. And therefore, the reason why we would choose a specific approach should be driven by our preferred principles rather than the other way around. What I'm saying here is before making these choices about how to build something, we should think about what we want, why we're building it. Because if we simply choose how to build something, that's going to guide the things that we then do. And that might not be the principles that we want to follow. That might not be the system we want. And it might lead us to make decisions that are not the best for our system because we think a certain pattern is going to solve all our problems without knowing what problems we're trying to solve. The rest of this talk, we're going to kind of hinge off that. So if you don't like that quote, you could maybe go for a break around now because maybe you'll disagree with the rest of the talk. Or maybe not. First, we want to look at what microservices can teach us about logical systems. Microservices split separate business functions into separate systems. This maps our business, means we have to have a good understanding of the business, and it decentralizes our services. And those services have clear interactions with one another via APIs. We define a boundary, we define a contract on an API to say how I can be interacted with, how my service can be interacted with. And unrelated code, therefore, ends up living in different code bases. And that's going to reduce coupling. It's going to reduce the way we can distort those boundaries within our code, within a single pull request, for example. And so what are the principles we can draw out of that don't relate to microservices, but are just good principles for good software? Well, they are decentralized services, clear interactions, and to reduce coupling. I've mentioned coupling a few times. This might not be a familiar term to everyone. Let's dive into why coupling can be a bad thing. In this case, we have an application. Let's imagine it's a blog application. And the new requirement has come in to allow a user to have a viewable profile. So developer sets to work on an endpoint that's going to return a user's profile to the front end. And this developer is a good developer. They know not to rewrite things. They know not to rebuild things. They know to look for something that already exists. So they hunt around the code base and they find a method on a service that seems perfect for their use case. Get user by ID. Well, that's what I'm trying to do with my profile endpoint. They're submitting a HTTP request with an ID. I want to get a user and return it. Boom, job done, early lunch. And so they can pull in the service that provides that method. The service is called auth service. Fair enough, auth service would need to know about users. So they pull in the auth service and they get the user by its ID and they return the response as JSON. Jobs are good. And then we have to wonder, what does that auth service do? And the thing is, services, functions can be black boxes. We have a method signature, so we know what the method says it does, and it's got a name. Get user by ID is quite clear. But let's look at the implementation of the auth service. And the auth service goes to a repository and finds the user. And then it calls this method with JWT. Now, JWT is a JSON web token. It's used for authentication. Now, the auth service is taking a user from our database and it's tacking on a JSON web token and sending it back. And that JSON web token presumably can access that user's account. And now our profile endpoint, which is public, has just exposed that user's JSON web token to anyone who cares to look. So with very little control, with very little visibility over this issue, we've exposed a large security problem in our application due to unintended coupling. And this is where microservices are built as a way to reduce that. In a microservice architecture, we would have a set of independent services which talk to each other via APIs. And so if we want our one system to get a token, it has to specifically get that token. And if a system needs to make a method to get a user and it doesn't have one, it has to write it rather than getting it from another system. Because that other system probably doesn't expose a get user method to just randomly give you any user's token, because that would be strange in a system which is about authentication. And these systems might be defined with something like Swagger or Open API specifications. So we say what we can do. And here's an example of our process in our order system. So we have orders, we have a payment system. Our order system is concerned with orders. Our payment system is concerned with payments. So they are separate services. And here's a flow we can follow from a user submitting a checkout form. We can check in the order system if it's valid. It's a valid order, so they've ordered the right number of widgets. I don't know why everyone sells widgets, but apparently we're selling widgets. And we're then going to send the card payments details to the payments API. Our order service isn't interested in your credit card by design. So we have to send that over to the payment service to make the payment service aware of your credit card. But we've got to validate your credit card information first before we can try and charge it. Because if it's wrong, we've got to tell you. So we're going to say the payment details are valid. No. Well, we tell the order service and the order service tells the user. And here's an example of a HTTP handler for that payment service. We get a request. We decode some JSON. If we can't decode the JSON, we return a 400 because it's a bad request. And then we verify it. And if we can't verify it, we return a 400 as well because it's also a bad request, but kind of for a different reason. The first bad request was because I guess something went wrong in our order service talking to our payment service. The second bad request was because the user's card details were wrong. So that's a little bit confusing, but we've left it to do in the comments, so that's probably fine. And herein, I think, lies an issue with assuming that we solve all our coupling issues, we solve all our communication issues just by moving to microservices. What we've done here is just move the problem into a slightly harder to reason about domain. We now have the problem that if the communication service between two of our services goes down or there's a mistake in it, it's hard to tell if the problem's the user's problem or our problem. And it's also hard to reason about whether these systems are coupled or not. We're exposing an API surface. We don't know if anyone's necessarily using it. So I want to dig into the principles that we're trying to follow here and the techniques for following them well in either kind of architecture. Well, a technique for building a good logical system is to build good APIs. That's a clear one, and microservices compel you to do that. The solid principles of object-oriented coding are also very valuable in building logical systems. Also, we can use code quality and static analysis tools. And finally, techniques like domain-driven design can be adopted to ensure we actually understand what we're building. So first, good APIs. Here's an example of our system in a monolith. And you'll notice it's a bit smaller. We say the order valid, we say the payment details valid, done. And how can we do this? And how can we say that this is any way better than our microservice architecture? Well, an API can be internal. And it's worth thinking about this when we're building our classes, our methods, that when we build a public method, we are building an API. It might not be called an API, it might not have a HTTP handler, but we're building an API. And to build an API, we need to think about that interaction. We need to make clear what the interaction can happen. Here's an example of handling this internally. And one cool thing you can do when you're building an internal API is you can go beyond something like a JSON payload and you can define objects. Those objects can be at any level. Here's a card details object, which knows it has a card number. And we've made the card number a string, but we could just as easily make a new value object called card number, which only can be a valid card number. And that way we know that we have valid data when we're passing our object model around in our system. And the thing is that we've got this diagram we had earlier of services. And it turns out that just by replacing the word API with function, we sort of have the same map within a monolith. We've still mapped out our services. Our interactions are actually now clearer because we can check which functions are called by which other functions in our service. So it's still an API. It's still a way of describing services. We can still have quite independent systems, but we can do that within a monolith and get the same advantages. The solid principles of object-oriented programming. If you're not familiar with solid, I do encourage you find a talk, find a book to go over about the solid principles. I think a lot of developers, from my experience at least, and I know I did this when I first came to solid, they read single responsibility and then they kind of just give up because single responsibility seems like it makes sense. And the next one is open and close and you're like, I'm not sure what that is, and you stop. Go through the whole set of solid principles, especially single responsibility and interface segregation are very heavily involved in microservices, but this set of principles is not a microservice handbook. They can be applied to any object-oriented system, and you should really consider adopting and using them in your systems. And finally, static analysis. I mentioned static analysis tools. Well, if we're going to put everything in a code base, Mike, we're going to have that same problem you said at the start, where some developer exposes all our users' JSON web tokens. Well, here's a little technique that we've started following internally. Is to use SAM internal. SAM internal is a doc block element for the SAM static analysis tool. SAM and PHP Stan are the two sort of standout static analysis tools that are, I think, under very heavy use in the PHP ecosystem at the moment. If you're not using either, use one of them. My personal preference is for SAM, but that is without having really tested PHP Stan. So that is not any sort of recommendation to choose one over the other. But SAM has this function, SAM internal. What SAM internal does is I can say that this class or this method on this class can only be used in a given namespace. So this auth service can only be used in anything with a namespace at authentication. And when I try and use it outside of that, I get an error. And this is great because now your code quality tool is telling the developer off for breaking service boundaries, even when all the code is in the same code base. And you gain a great deal of scoping in your system for this. One point I will make around that is that this is how a lot of PHP applications are structured out of the box, and especially if you read tutorials. We have a controller's namespace, an exceptions namespace. The problem with this is it means that related things are living in completely different namespaces because our namespaces are about what things do rather than who they are or why they're doing it. All I suggest is that you can flip this around. You should have a namespace for your authentication. And within that, you can have a namespace for controllers or a namespace for exceptions. This way, you can use something like SAM internal to truly lock down where public methods of a service can be used, even if everything is residing in the same dependency injection container. And finally, domain-driven design. Again, talks, books, conferences on this topic. I'm going to scratch the surface. But domain-driven design means we map out the domains of our business as subdomains. And then we look at context within those. So one interesting thing we'd see if we try to map out our context for our ordering system is that whilst our authentication and order subdomains are separate, our orders and payments contexts actually live in the same subdomain. They're very heavily related. They still have a bounded context, and we have to map those interactions carefully, but they are much more related than, for example, authentication and orders. And we can see that from just mapping out our systems in a DDD style format. What's next? We want stable systems. Stable systems. We in microservices, we are told we can scale systems independently according to their use. And we can balance the workload by splitting things across those systems. We can move something from one heavily used service to a slightly less used service if that helps balance our workload. If we're using multiple services, we are driven to using something like infrastructure as code tooling. I'll talk about that in a moment. And when you have independent services, you've got opportunities for experimentation. You can tack a new service on somewhere and just sort of see how it works. And you can replace a service or roll it back. And the principles here, again, I've crossed the first one out. We'll get to that in a second. We want to split workloads. We want to use infrastructure as code. And we want to promote experimentation. These are things that apply broadly, regardless of your architecture. And scalability, let's look at our network communications. This is our same service diagram as before, but this time we've mapped out where our services reside. So we've got a few services living in Kubernetes. We've got something on Amazon Lambda. We've replaced our auth service with a third party auth altogether. And we have a variety of protocols between the systems. Earlier on, I brought in a graph that I said was a software development process. And it'd be remiss of me not to make the cheap joke that this is also microservice architecture. There is a danger when we decide to start splitting our services out that we go a little bit too far. We are so preoccupied with whether we can do something, we don't stop to think whether we should be doing it. We can pull things out in so many ways and try and get so many different interactions between them. And obviously, you've got to be using protocol buffers and gRPC because that's cool right now. Maybe intra-service encryption with sort of different keys. And we can get a little bit taken by that and forget why we're doing any of it. And the techniques to build stable systems, I would argue, are that we want systems which are comprehensible are more important than systems that are scalable. We want to look for asynchronous boundaries in our systems. We definitely want to look into infrastructure as code. And I'm finally going to put out an idea that I call satellite services. So firstly, what is web scale? Scalable systems. We hear the word web scale. Make sure it's web scale. That generally means that someone thinks they're building the next Uber. They're going to build this app and it's going to start by being used by like 1 or 2 people. And then within a week or a month, it's going to be used by like millions. Okay, so we need web scale. It needs to be a handle being used, distributed all over the world, millions of requests a second. Sorry to burst your bubble. This probably won't happen to most of the systems people are working on. And in fact, the time development teams are spending trying to satisfy this desire that something is web scale from day one is probably a reason why the business itself is going to falter, because you're not building the features that your customers need. Instead of focusing on, is something web scale? Can it scale up 10 million times? We should focus on a few basic things instead. Separate your data storage and application serving. This isn't a microservice approach. This is just sensible. Taking your data and putting it on one box and your application on another box, having a network link between the two of them, is going to allow you to do a lot of scaling and a lot of important things like backup, and a lot of things like cloud migrations are going to be much easier in the future. Even if you have a box right now in a data center, get another box in the data center and move your data onto that box. And the second thing I'm going to say is going to be strange to anyone who watched my talk at DPC last year when I came on promoting a varied range of different database types. But sometimes a big database server can be better than fancy tech. If you want your application to handle 40,000 requests per second, maybe using a brand new proprietary database technology isn't what you need. You just need more cores and more memory in your existing box. And yes, you'll pay for that. And yes, you'll be over provisioned. But maybe that is much, much simpler than trying to learn an entirely new technology that has its own pitfalls and something you're not aware of, just to achieve, again, a goal of scalability that you might not need. And one thing we can learn from microservices is about asynchronous boundaries, job queues, ways of moving processing out of a user flow and into a background flow, into a place that gets processed slightly later. So on that topic, what is an asynchronous boundary? Here's a process flow, again, from my ordering system. We've got a process where we check some stock, we verify the user details, charge their card, schedule the order with our dispatcher, shipper, whoever it is, and we send a receipt. And in this process, most of this needs to be done before you tell the user their order has succeeded, because if any of these go wrong, the order hasn't succeeded. But we have an asynchronous boundary, sending the user a receipt. If the user gets their receipt a few minutes, 5 minutes, 10 minutes later, it's probably okay. And in a lot of our systems, we're going to have these asynchronous boundaries. And when we do, even if we're not building a microservice system, it is completely okay and a sensible thing to send these off to a job queue and process them later. And we can do this here. We don't need separate microservices to handle something like a job queue or even an event bus. We can run that all from the same system with its advantages of sharing the code, with its advantages of using the same thing, of all the developers running the same stack. And we can run different processes inside our monolith that still leverage these microservice advantages. Infrastructure as code is a similar thing. The tools are just as useful in a monolith. They tend to be essential if you're building microservices. But if you are anywhere hosted on a cloud platform, even if you just have a couple of servers, a few resources, investigate Terraform. It will work for all the major cloud platforms and a lot of the sort of second tier cloud platforms as well. You can define your resources, you can map out their interactions. It's fantastic. Packer is actually brilliant for monolithic systems because you can build base machine images that you can run all your stuff on without having to worry about things like containers. And Packer can rebuild your machine every week. So all dependencies are up to date and you can build out a machine for staging or build out a machine for user acceptance testing. And even Docker Compose, again, something that's very associated with microservices because it composes lots of containers into a network to build something. You can map coupled services together in a sort of monolithic structure, micro monolith, I guess you could call it, where you have a code base, but you're running different parts of the code base as parts of different services. We actually do this for a few services, especially where we have heavy use of caching systems. So we deploy a single chunk of code, but Docker is running services alongside for us. And that kind of extends nicely into satellite services. Again, there might be a better term for this. I say satellite services because it seems nice, the idea of like services orbiting your monolith. A satellite service is a satellite. It's a separate small thing up in space orbiting a huge thing. So you still have a huge thing, you still have your monolith, but then you have your satellite going around it. And your satellite provides extra functionality to your monolith, whilst not being essential. If your satellite goes away or crashes, then your monolith is still fine. You might want to get a new satellite up, but the monolith's fine. Satellite services tend to be for asynchronous activities. They can be great for prototyping. In that case, you can kind of land the satellite when you finally decide this prototype is going to come down to the planet's surface and become part of your system. You can bring it down and actually integrate it with your monolith. And they're often used for secondary concerns. So things like analytics, an emailing service. Your business is generally not about doing analytics. Analytics is just something you have to do because you have your business. Same with emails. And they're also good for cross-cutting concerns where you have the same need everywhere, like logging. You might log in all parts of your application. So you need a system that's kind of separate from the application to kind of watch those logs. And I refer to those as satellite services. The third thing we wanted in our list at the start was flexible systems. What can a microservice teach us about flexible systems? Well, it's hopefully not a surprise, but smaller services encourage fewer dependencies. If we are mapping our services, because we have to build microservices, it places a focus on system design. And that actually also leads to teams and services understanding not only their interactions, but the overall business scope better, because they kind of have to understand what the downstream implications are of what they're doing. And it means that tests must branch beyond unit tests and into acceptance and integration testing. Once again, we can pull out some principles for this, which are independent of architecture. Fewer dependencies, focusing on system design, and a move towards acceptance and integration testing. One thing I will say on this is if your system is already broken, breaking it into lots of pieces doesn't help. Okay, if your system is already broken, simply splitting it up into services doesn't actually make your system any better. So what actual techniques can we use to build a genuinely flexible system that are independent of the architecture type? We can use established languages and tooling. We can reduce the number of third-party dependencies. We can plan our systems better. That might strike a nerve for some people. And we can focus on testing and code quality. Established languages. This is a graph from Stack Overflow's developer survey, 2021. And it shows the developers who are actively using different languages in their profession, along with a sort of weird set of interactions, which looks kind of beautiful, but I don't really know how you understand it, about where those developers working in one language want to go next. We can see JavaScript, Python, SQL, TypeScript are very popular. Established languages means that you can hire developers to work on your project. And it's maybe a pertinent point here at a PHP conference to look at the size of that PHP line. That line is looking a little bit small. And it's probably just worth, this is not to do with my talk, but it's probably just worth a general thought in the PHP community. How can we grow that line a little bit? Because the bigger that line is around the edge of that graph, the more chance there is of finding developers who can work on our projects with us. And the more safety we have in choosing PHP as the language for building things in. Food for thought. This isn't PHP, this is JavaScript. This is left pad. This is a function that adds padding to the left side of a string. It's very simple. Left pad, people might be aware of, was subject of a bit of a debacle a few years ago when lots of developers, for reasons known only to them, were pulling in left pad as an NPM dependency, and the maintainer of left pad took it off NPM and basically broke the internet. Now, this is a very simple function. Let's look at it again. I would imagine that I should be able to ask any developer in an interview to write this for me without any reference, and they should be able to do a reasonably good job. None of those developers needed to pull left pad in from NPM. And in fact, I think it was generally a silly move that hopefully the industry has learned from. Sometimes you just need to write it yourself. This again goes in the face of a lot of common wisdom, or always look online for libraries. If your library is doing something kind of weird and kind of complicated, like crypto, and I mean cryptography, not fake money, then you want to be using something established and tested and proven. If you're doing HTTP, there are probably enough edge cases you want to be using something like Guzzle. If you're doing padding a string to the left, I imagine you can write that yourself. And in fact, everyone should probably have a go at writing a curl handler or or something to handle an OAuth authentication flow themselves once in a while, so they actually understand what their systems are doing rather than just using a library. Doesn't mean you necessarily use all of those complicated things in production, but it's worth having a go yourself. And it's definitely worth reducing the dependencies in your system. Look down your list of dependencies. Are there things there where you're using like one function from an entire library and you could just write that function yourself? I mean, you could copy and paste the function, okay? If it's open source, especially if it's MIT licensed, you can just take it. And the problem with microservices can be internal dependencies. Let's not assume microservices are immune to this. It's quite common in a microservice architecture for teams in a business to share internal libraries that map to common functions everyone needs to do. Maybe there's a common process that all teams need to do to verify a user ID is valid, and they don't want to separate it via API because they want to do it fast. Well, they put it in a shared library, or things that map to a database, ORM entities. We share those out, but then there's a problem when one team wants to upgrade that library, another team doesn't. We actually end up with internal version conflicts, and people moving from one team to another have a real big problem of going, oh, I've moved to this team, and they're on version 1 of the thing I was on version 2 of. I don't know how to use that anymore. Even internally, we suddenly lose this knowledge transfer because we end up getting tied up in dependencies. So it's kind of the reverse problem of too many dependencies. It's the internal dependency problem. And it's worth being aware of if we're thinking that microservices solve that problem. They don't. They just mean we still have to think about dependencies. I'm calling this that design bit. I mentioned design. Fully half of the traditional waterfall and the traditional sprint model diagrams are about design. But I find in general that sprint is that thing that a lot of developers do past the design stage of work. That's not a pop at developers. We are people who love solving problems. We love tinkering. Most of us are in this field because we are creative people whose brains bubble over with ideas when we see a problem. And that means that we tend to rush into getting code down on the IDE or on a server to try and solve a problem before thinking about what we're doing. Again, microservices tend to force design because if you don't design your microservice, you just have a bunch of services screaming into the void. In a monolith, it can be easier to kind of do design later by just repointing things. Let's avoid doing that. Let's actually design our systems before we build them. Even your little prototype, spending a bit of time designing it is probably going to save you a lot of time in 2 years from now. Future you is going to love you if you spend good time designing your systems right now. And testing. Unit tests are great. No complaint about PHP unit or any other unit testing framework. But we need to imagine that our systems go beyond unit testing. And not only, I'd say, go beyond unit testing, but actually the focus of our testing, I would hesitate to say, should be on integration or acceptance testing. We're generally building complete systems. Even if we're not microservice based, even if we're a monolith, we'll have a web front end, we'll have a database. Those in a way are like microservice interactions. They are separate services we need to test interactions with. If we are simply relying on unit tests, 100% unit test coverage, we're going to miss all those interactions between systems. Again, microservices, you have to test the interactions because otherwise you have no clue if your system works at all. In a monolith, we can sort of get away with it for a little while, but eventually it can come tumbling down. If you are new to integration testing, where you kind of involve things like file systems and databases, or acceptance testing, where you generally involve like a browser or a mobile front end, I thoroughly recommend Codeception. It's a fantastic test suite. A lot of its unit test capabilities are just consuming PHP unit, but it adds a huge amount of stuff for integration tests. It's got modules that integrate with frameworks. It's got a BDD style language for browser testing that integrates with Selenium or other web drivers. It's got a truly heroic, I think, developer. I think it's worth your support, and it's worth using if you don't use Codeception at the moment. And so, starting to wrap up a little bit here. You might have a question. We're already on microservices. Some people out there, and I don't know if it will be a majority, but definitely people in the audience will be already on microservices. And maybe they're listening to this talk and thinking, should they go back? Maybe not. Maybe I've not done a good enough job, but they might be thinking that. And the answer is it depends. Sorry, that's a bit of a lame answer. Probably not. But it's worth thinking about. Do you know why you're using microservices? Now, remember, that doesn't mean you shouldn't use them. A lot of people don't know why they're using a monolith until someone points it out to them. But if you're using microservices, are you confident that the challenges of your business are best solved by microservices? Maybe, maybe not. Now, here's the kicker. Is the microservice implementation causing more problems than it's solved for you? Are you sitting there having trouble managing internal dependencies, managing system interactions, drop network packets? The amount of times a network packet drops is considerably more than the amount of times a function call just doesn't happen. Are you handling those problems? Are you trying to fight with those problems? And maybe you're thinking, oh, how can we make our microservice system better? And the answer is simply the monolith would be a better place for you. Can you spot cases where you'd benefit from a loved monolith approach, an approach where you take all this knowledge you've gained from implementing microservices and put it into a monolith? Can you fold your microservices together, move them into a mono repo and start processing them as if they're one code base and progress towards a monolithic structure that's going to make your team interactions easier because you're going to take the knowledge you have of microservices and bring it back to a monolithic structure? Maybe that's the case. But in conclusion now, for everyone, principles should inform practice and not the other way around. So choose your principles. What matters most to your software, to your business, to your team, to your system? The benefits and advantages attributed to microservices that you'll see plastered over the internet can often be implemented by understanding them and understanding why they're there into your monolith. If you have a monolith, that monolith probably has business value beyond just the problems that you see with it. It probably has edge cases that a user asked for 3 years ago that you implemented, and it's a sort of rough, bumpy edge. You don't like the look of it. It's hacky, but it works and it's providing value to a customer. And removing it means you've lost that because you lose that knowledge as well. So rebuilding generally has more expense than just improving something. Even if those improvements require paradigm shifts and require your team to learn new things, because we all want to be continually learning new things. Hopefully that's why we're at this conference. And so with that, I say thank you for your time. If you have questions, I don't think we have time on the stream to ask questions, but I'm welcome to them if Cal wants to ask them. You can tweet me at M1KE on Twitter. I am happy to respond. I will jump in the DPC Slack channel later on to answer questions that people have put there. Please do use Joined In. And if you want to find me and chat in general, I often hang out on the OG AWS Slack channel. But once again, thank you for your time and thank you, DPC, for having me talk today.
Thank you so much, Mike. I do appreciate that. That was a great talk. I look forward to reviewing the video of that one. It's actually applicable to a problem that my team is currently working on. Hey, I hope you've enjoyed this. Don't forget, go out to Joined In, register, and leave Mike some feedback. And also, if you've got questions, Mike did go right up to the line. So we're going to push all the questions over to the Slack channel. But over in the Slack channel, Mike has his own room. Go over there, pop in, ask him any questions you might have. Okay, we'll see everybody back in 15 minutes. Back right here in 15.
Thank you very much.